IP routing. What do we mean by routing, and what we do in routing, and what is the purpose of doing routing? So, like I said in the previous class, routing is just, transferring of data, or the process of transferring the data from one network to another network. So what we are doing is, forwarding packets from one network to another network. And how we do it, there are multiple kind of routing protocols which are available, which we use to do this. So routing protocol, and what is routing protocol basically? A routing protocol is, is something which helps you, or helps the router in, routing the data. And how does it actually do it? It basically advertises. What does it advertise? It advertises the networks, what it knows of, whether its own, what it has in its own routing table. You will understand it better when we do the lab. What I'm trying to say is, whatever the routes I'm advertising, whatever the routes, the network I know of, or myself advertising, or what I have learned from others. So that is how they propagate this information from one to another. So that is how, you basically know about the routes to go from one place to another place. Or maybe there are, so what we are saying, this is from routing perspective, but then I told you there are different kind of routings, like static and dynamic. Static, wherein you do all the configuration manually, you tell about the different routes, whatever you configure on the router, then router comes to know, okay, this is how I need to get to that particular network. But in dynamic routing protocols, there are, if there, there are any changes happens, if there are any, if any changes happens in the network, either by dynamic routing protocol, or somebody do, manual entries of static routes. So those changes, how, how you get to know. There are updates, basically routing updates, which comes from different devices. So those routing tables, those updates, when it reaches any router, it actually compares its routing table with that update, that do I have this information which is coming to me in my routing table or not. And if not, then what is missing, then maybe what I need to, how I need to update my routing table and all. So we will see that during the labs. So by giving the, network changes of the latest update, you update basically your neighboring routers. If you are advertising, then your neighboring router will come to know, okay, what you are doing, or what are the latest changes in the routing protocol. And also, there is something called as, which you will hear a lot, what we call it as keep alive, something known as keep alive. So this is the term you will, use your entire career. There are different kind of keep alives, basically to know that whether my neighbor is alive or not. And then there are different kind of keep alives you will come to know. So basically informing the neighboring router that what, that I'm there. Okay. So that is what name also suggests, that keep alive. So there are different kind of keep alives in different kind of routing protocols, and in different scenarios, not only just in these routing protocols, but in different kind of scenarios. So now few examples which which we already talked somewhere in the beginning or somewhere during these classes, but we will talk about them. There are different kind of, I'm just telling you the names, but then we will talk about the classification as well. So there are different kind of routing protocols like RAPE, OSPF, EIGRP, and ISIS, BGP, and should I tell you the others? No, I'm not talking about others which are at the data center level. In CCNA, people generally talk about all this. This is again, you don't talk about it now. And this is when you, I would say, when you learn around CCI data center. So this is a kind of data center stuff. BGP, you don't learn at CCNA level, you learn it at CCNP level, but you only get to work on BGP if you are a core network engineer. If you're working on networking only, working as a network engineer. If you are a security guy and all, you will never see BGP in your life. If you are a core network engineer, or somebody who's working on an end-to-end network. So what I mean end-to-end is, you're managing routing, switching, you're managing security, wireless, everything. There are environments where a single team manages the entire infrastructure. But in most of the enterprises, there are different teams for network engineers, there are different team for network security, like that. So this is, I would say, a typical, and network engineer role. But this comes at, not all the network engineers work on BGP, so it actually needs a lot of knowledge, need a lot of. So no, I'm not going to say much, but this is the protocol, you can say, responsible for your internet. This is what I'll say at this level. Yeah. So BGP is what your internet understands. Your OSPF or RAPE or EIGRP, they are your enterprise routing, dynamic routing protocols, but they are not your routing protocols which are understood by. They are just for the enterprise, or you can say your area network, local area network. Not. Not. I. I should not say local area network, but then the whole enterprise. On internet, it doesn't work. BGP is the internet routing protocol. Okay. So yeah, and there is another, I think, what you call it as. We talked about it, right? Routing protocol and routed protocols. And what was the routed protocols? IP, IPX, or earlier there used to be Novel and all. So this is basic, understanding of, what RIP and all we will talk about. But again, RIP, I'll do a very little introduction, and maybe I'll show you lab, but this is unuseful. You will never see in your life anywhere, in any enterprise or in any network. This, what I say, while I talk about RIP, it's routing information protocol, the full form, but then the RIP got RIP the day it got introduced. So RIP is not anywhere. And the most the protocol which you will see on enterprise level at, I would say, 90% is OSPF. So that is what your enterprise level. You won't even see EIGRP, even that is not that good or scalable. And then we'll talk about it why. And yeah, EIGRP, you might see in some scenarios somebody likes EIGRP in some particular scenario and they have used it there. But this is the most scalable routing protocol in many senses. So yeah, so you will come to know once we learn about it. And then there are a few classifications like IGP, interior gateway protocol, or exterior gateway protocols. We talk about that. So yeah, so I think, yeah, let's talk about classification, a little classification of the routing protocol. So what we call it as classful and classless. So just to give you a little example, classful is, it's again similar to what? Subnetting. So RIP used to has two versions, RIP version 1 and RIP version 2. So RIP version 1 was your classful you know routing protocol. It's useless to, because this classification is there, but then it is not implemented. So I'm just telling you or informing you just for the sake of knowing it. And then there is classless. What we have under classes is rest of the dynamic protocols like RIP version 2 or OSPF, or EIGRP, or your ISIS, or your BGP and all. They all are, you know classless. So what I mean by classless, what you mean by classless subnetting, the same idea is here. So you are basically advertising classless subnets using these dynamic routing protocols. So that is the difference. Okay. So yeah, so these are what we call, and then what I talked about is IGRP, or sorry, IGP or EGP is basically interior gateway protocol, and then exterior gateway protocol. So E are all interior, okay, IGP, and then EGP, interior gateway and exterior gateway protocol. So all the protocols what we run at enterprise level, they are interior gateway protocols. Okay. And your EIGRP and your ISIS, and then you can say BGP is uh, exterior border gateway protocol. But then there are two things, EBGP, IBGP, because we are not talking about BGP, so I'm not gonna tell you more. And again, don't think that I'm not telling you. The idea is you will not remember it. So I mean, if you don't work on it, it's useless. Any technology. So that is what with BGP is. I mean, most of the network engineers, being network engineers, for like 7 8 years, they never get to work on BGP. BGP is an advanced step. It totally depends on what you're doing in your organization or what your role is. So talk about BGP when you're working on BGP. Otherwise, it's useless. So I mean, this is, you can use BGP as interior gateway protocol as well. So that's all I'm going to talk about BGP. So yeah, so these are your interior gateway protocol. What you are, you know, maybe I should say, running inside your enterprise. Okay, and then there is another classification, what we call it as static routing protocol and dynamic routing protocol. What we said right in the beginning is static, you know, right? All the static routing, the manual routes, which we'll see, and the dynamic routing protocols. These all are dynamic routing protocols. But then there are a further classification based on what kind of algorithms they use in backend. So one is known as distance vector, and one is known as link state, and another one is known as hybrid. Okay, so the examples of distance vector is, I would say, let's say RAPE, and link state is your OSPF, and hybrid is your EIGRP. Okay, so we'll talk about that, what is distance vector, what is link state. Okay, and then when we talk about link state, then we'll talk about LSA and stuff, basically link state advertisement and all will come to go. And there is something called as autonomous system. So maybe not at the moment, or maybe let's talk about this. So autonomous system is, I would say, let's say these are some of the routers, how they are connected. Let me know, guys. I mean, if you have any questions, just raise your hand and then we'll discuss. And this is another area where some of the routers are there. Okay. And let's say this is one enterprise, or let's say this is one ISP where they are providing their network. Let's say this is Airtel, and let's say this is Geo or Reliance, or let's say AT&T. Okay, and then they are connected. This is one enterprise, and let's say this is VGP, or let's say EBGP. Okay, over the internet, or let's say even in the internet. I mean, so the area, the boundary, which defines the area of one particular enterprise or one location is known as autonomous system. So basically, the boundary which covers a particular domain or area or enterprise is known as autonomous system. Okay. But in BGP, like I said, it's internet protocol. There are AS numbers which are there in BGP. I mean, on internet also there are different AS, autonomous system numbers or areas which are there. What we use in BGP. Similarly, I mean, because from IGP perspective, I mean, this is how we basically define that this is one area, this is another area, or you can also define. Let's say I have different OSPF area. I mean, what we in the area concept is there in OSPF. We'll talk about it. So this is maybe when we configure, then I'll tell you what is the significance of AS number and how we use it in real time. And I think maybe at that time it will make more sense to understand. And then some of the uh, important things are, I mean, under dynamic routing protocols, so protocols use something known as metric. So metric are again the classification, or of certain components or the criteria used by routing protocols to basically decide what path or which path or why this path is to be taken for data transmission. So basically it's the logic, you could say, using certain criteria, that I'm using these criteria to decide that this is the path I'm gonna take to forward the data, or to forward the traffic. Okay, so and now what I talked about is AS number. So there is a range of AS numbers. It actually starts with 1265535. You can check. I mean, you Google yourself that what is the significance of this number. Maybe you tell me later that what is the logic behind this 65535. You will come to know there are a lot of things which are, there, you can say, uh, behind this. So again, AS number, let's say this is, I told you the example. This is, let's say, Airtel over the internet, some of the components connected over, let's say this is EGP, and this is, let's say, here some IGP is running here, and this is, let's say, AT&T, and then let's say this would be some AS number 100, and let's say this would be some AS number 200. So this is again I mean, an area of network which has its significance, and AS number for now you can understand it as the tag that is defining that this AS number belongs to this particular area. So this is basically for now. This is for you for now. This is a tag identifying the location of a particular network, that these routes or this area or whatever routing updates or route which we are receiving from this AS number. So they are talking about a particular network or location. So you can maybe, think of that way. And then there is something called as AD value or administrative value. So this is something uh, which you will see or you will use all the time, known as AD value. Okay, so there are different kind of ranges and values which are available. So static route, what is the, so there are two things. One is, I mean, I'm just making a note of it. Exit interface is 0 and next hop is 1. You will come to know what is this. And then RIP, what is the AD value for RIP is 120. For OSPF it is 110. For EIGRP, again EIGRP used in two ways, internal and I mean, it's like IGRP and EIGRP, two kind of thing, internal and external. So for internal it's 90, and for external it's 120. Sorry, 170. I mean, these are default values, okay, but they can be changed. Okay, I mean, this is just the theory. I mean, even if it doesn't make any sense to you at this moment, and there no worries. I mean, we're gonna, you know, talk about it while we do the labs, then it will make more sense. So one example around the AD value, what we call the lower is the better. Okay, so 0 is the most reliable, and we will come to know that what I mean by this reliable. So I mean, like I said, AD value is again one of the metric in route selection. So there are different kind of matrices which are there, but then there are different kind of metrics, not matrices, metrics which are there. So I mean, the lower is the better, and so you will see that. For example, let's say uh, this is one router, and then let's say this is one router, and this is how they are connected to some network. Let's say this is a 10.10.10.0 network, and then similarly there is another router, and similarly there is another router. Let's say this is a RIP link, and let's say this is a OSPF link, and let's say this is a EIGRP link with external. So or internal, maybe internal. Yeah, internal. We are doing internal only. So what is the route based on AD value you can think of should be preferred out of these three to reach from here to here? Hmm? I mean, I just said, right, this is 120, this is 1110, and this is 90. So this is the route this router is gonna use to reach from here to here. Like I said, I mean, AD value is one of the metrics to determine or to do the route selection. Okay. All right. Okay, now let's talk about static routing. Second. So routing is fine. I mean, we talked about this, and we talked about this yesterday, that what is routing and what we do, best route selection and all. So this is fine. Route types, we talked about static, dynamic and all. And what? So okay, IP routing, static default. Yes, we did not talk about default. So default is again, yeah, I mean, you can make a note default route, and we will talk about that. What is default route? Okay, now let's talk about static route. All right. So maybe I'll draw one topology, and then we'll discuss. Let's say this is one router here. Let's say R1, a PC is connected here, and let's say this is R2, and another PC is connected here, and this is R3, and we have another PC connected here, and R4, and we have another PC connected here. Okay, and let's say the IP address of this PC is, this PC belongs to 10.10.10.1, and this is /8. Okay, and this is 20.20.20.1/8, and 30.30.30.1/8, and this is 40.40.40.1/8. Okay, so this is the same segment, right? This is the same layer 3 subnet, because your router, we talked about what in the previous class, a router is the inter-networking device between two different networks. So this has to be a different network, and this has to be a different network, correct? Likewise, this has to be a different network, and this has to be a different network, and likewise this would be a different network, and this would be a different network, correct? I mean, they all are different networks. That is what the router does. Yeah. So what could be the address of this? I mean, this is basically, this link is 10.10.10.0/8 network, right? So maybe let's say this is .2, or maybe 10.10.10.2, yeah, /8, correct? And let's say this particular subnet is 50.50.50.0/8, and let's say this is 60.60.60.0/8, and let's say this is 70, and let's say this is 80, this is 90, and let's say this is 100. Making sense? I mean, it is okay at the moment. And what I'm gonna say is, these are .2 and .1. Okay, .2, .1. And what is this interface? Let's say this is F0/0, fast Ethernet 0/0. Let's say this is fast Ethernet 0/1. Let's say this is fast Ethernet 0/2. Fast Ethernet 0/0, fast Ethernet 0/1, and fast Ethernet 0/0, fast Ethernet 0/1, and 0/2, and then this is 0/1, and this is 0/0. Okay, got it? I mean, it should not be a problem at until now. Yeah. So this is 10 network, this is 50, this is 70, 80, and this is 100, and no, I'm sorry. This is not 70. We talked about, I mean, what we said is this is 20, right? When the PC is 20, they are on the same network, right? So this is our 20 network, this is our 30 network, and this is our 40 network. This is 50, this is 60, and this is 90. Maybe let's make it as 70. Okay, no problem. So now what we know on each router, let's say R1. So what I'm gonna say is, what does the routing table of R1 look like? So what I know, so there are two routes. I mean, so this is what we call it. Let's say if this is A, this is B, this is C, this is D. So my R1 is connected to, sorry, A is connected to R1. And let's say if A need to speak to C, then how A will reach C? What it will do, it will, from here, it will reach this particular interface. Then it's on the router, right? The packet is now on the router. Now packet will exit from this interface, correct? So this would be what we call it as exit interface, because this is the interface from which my packet is exiting the router, correct? Now the packet reaches here and then exit from here. So this is another exit interface. Then it reaches here and then it will see the routing table that why which interface the C is connected. Then this would be the exit interface for this flow in this particular scenario. So it reaches to C. Then C replies back. It comes here. This act as a exit interface, entering interface, exit interface, and then exit interface, and then it comes here. What I'm trying to say is what are the networks what I know locally on this router, or what we call it as connected route. There are there are many kind of routes. First I'm talk about connected routes. So connected route is what I know locally of, or I am the originator, or maybe they are connected with me. So what are the routes or network which are connected to this router? One is 10 network and another one is 50 network, correct? So these are the connected routes. So connected route is one is 10 and another one is what?
50.
50. Correct. Now we don't know about 60. I mean, this router at this moment doesn't know about 60, 70, 30. I mean, 60, 20, 70, 30, or 40. So how it will come to know? It will come to know using the routing protocols, be it, I mean, static or let's say dynamic. And
Dynamic.
what does this router know about? It knows about 50. It knows about, this is connected, right?
50.
It knows about
Yeah.
60. It knows about 20, and likewise it knows about 60. It knows about 70, and it knows about 30, and this guy knows about 70 and 40. So what we need to do from here, I mean, this is 10 network and C is 30 network. What we are trying to do is we are trying to communicate from A to C. So, so this router should know about this network, 30 network, because my source is what? Source is my 10 network and my destination is what? 30 network. So my this router doesn't know about my destination. So this should know that to what it should know, that to reach 30, what is my next hop. And we talked about hop and all earlier, that basically where is my next stop where I need to go, or where is my next stop which I need to go to in order to reach here. So what are the different paths, or what are the different hops which are available to travel from here to here? So 1, 2, 3, I can say in this scenario. So what I need to tell this router that to reach 30 network, I need to go to what? I need to reach to where?
FA02 of R2.
I need to reach to R2, but where on R2?
FA02
Sorry, what?
first. FA02 interface.
Yeah, I need to reach here.
Yeah.
So this is where I need to reach here, correct? So I'll tell this guy, okay, to reach here, this is my next interface, or this is my
Next hop.
next hop. Next hop basically. So I'll tell now how I can tell. Maybe this guy is advertising. If they are running dynamic routing protocols, then they are telling each one that I have these routes. This will get tell about I have these routes. Then they will exchange that routing information, and likewise everyone will do it, and everyone will come to know that this is what we have, and this is what we have to share with each other. But on static routes, we will manually tell that okay, to reach this network, this is your next stop. Okay, so we'll see that how we are going to talk about it. So maybe we'll draw one topology. Like maybe let me write it here. So what we do is we go to router, and then what we do, we go to enable mode, then this change to this hash sign, and then we go to configuration terminal, basically global configuration mode. And then what we do, we execute the command. So to assign a manual route, the command is IP space route, and then your network. Basically, what we call is network, and then followed by subnet mask of that network, and then the next
Next
hop,
hop.
or
Address.
let's say exit interface.
Right.
Okay, this is what we define. So let's say to reach 20, not 20, to reach, let's say 30. So what I'm gonna write on R1, let's say IP route 30.30.30.0. Subnet mask is 255. Okay, say it's /8 I have defined. So let's say then it doesn't matter. I mean, what I do here. So what, anyways, I mean, if /8 maybe because we have done it like 30.30. So I mean, if it could be 0 also. I mean, if it is, this is only the subnet /8, then that doesn't matter. And then the next hop. So what is the next hop? Next hop would be what? Come on.
Entering interface. Sorry,
What would
exiting
be
interface. That is FA02.
50.50.50.2,
Dot
right?
two.
This is dot 2, right? This is F0/2, which is 50.50.50.2. So now what will happen? The now R1 knows about. So there would be a sign for static route is S. So now R1 also knows about what? 30 network, because I have given this route. So this entry would be like in this, I'll show you the routing table. At that time you will see how it is there in the routing table. So to reach 30.30.30.0, the next hop is 50.50.50.2. Okay, that is how there would be an entry. So this is connected what I have configured on my interfaces, or what is available locally, and this is statically configured, and then there would be dynamic, and that is again there would be notations like is it using OSPF or EIGRP or what you will see in the routing table. Okay, so this is how you configure. Now to this guy, this doesn't know about 30. So similarly we are going to configure the information about 30 here as well. So that is how it will reach here. Now this guy already knows about 30, so this guy will use its locally connected network to send the packet to C. Now C knows that to reach back to this network, I mean, it should also know, its routing table should also know, or there is a concept of default gateway. We will talk about that. I mean, if it doesn't not, if it does not know about the destination network, maybe it know about the default route or the default router, then it sends it to default router. We'll talk about default route. And then similarly, we have to tell about this guy. This guy doesn't know about 10 network at the moment. So we will configure our static route about 10, and then here we will configure a static route about 10. And that is how the packet will travel from here, and then the reply will come back from here to here. Okay. But in static, what is happening? Everywhere we have to manually, you know, input the information about the routes. So that is what one thing which happens in static routes, that we always have to do manual entry of the routes. And there are few advantages, there are few disadvantages. One is, I mean, when you use static routes, so basically no overhead. I mean, the minimal overhead on the CPU, because in dynamic routing protocols, they are using logics. So there is a consumption of CPU because they are doing their calculation and all. So, but a static route is just a minimal occupancy of a little memory. That is, I mean, almost similar, equivalent to almost zero. So that is, I mean, there is no overhead on, on the CPU, and there is no overhead between the bandwidth of the two routers, because I mean in dynamic routing protocols there would be exchange of lot of protocols, and not protocols, lot of information which they will share with each other to know what are the routes and all available. So there is a usage of bandwidth. And security is, I mean, it knows only locally, so you can't really tweak the dynamic routing protocol to to make any changes which can affect your network. From security, I mean, there are, I mean, how it's more secure, maybe when we talk about the dynamic routing protocol, at that time you will understand it better. And now the disadvantages are, being a network engineer, you need to have very good understanding around the overall network, or maybe at least the source and destination you are you are basically point A to point B what are the number of hops which are available, who knows about what. So you have to know about the entire network, because I mean not only the source and destination, there might be multiple hops in between. So I mean they are knowing about some other routes, and if you make any changes which might affect your flow from one direction to the, I mean maybe you are configuring certain routes here. I mean, there are chances. So you will understand it better when you do bigger topologies, that this is how I have defined one flow. Now I am configuring a static route. So that should not change anything which is already there. The existing traffic flows of other directions or other source and destination. So that is one risk. I mean, I mean, if you don't know about if you're not sure about the end-to-end routing, then it's difficult. Otherwise, it could be, it could be a problem. So during, I mean, in real time, whenever you in your real-time production environment, whenever you configure any static route, or there is a new requirement which leads you to, do a lot of routing changes, maybe manual routing changes that is static, then you need to be very careful. So that is what people do. I mean, they analyze the entire network, that this is the flow, this is what it is configured on different hops or devices, and if I'm going to make these routing changes, so you have to be very careful, you have to calculate that what and all, how it is going, and so that could be risky. So the point is that you need to know the entire network, okay, or at least a piece of network which holds that flow, or it doesn't, because there are then dynamic routing protocols, and I mean your dynamic routing protocols also advertise your static routes, how they advertise in real time, or how it actually happens on the device, we will see. So that can impact your network, okay. So yeah, I mean, and it is like it says not feasible in large network. So the idea is to say is, I mean, it's not like that it's not configured in the large network. uh, uh, but one second, guys. Okay. So, but I mean, the idea here is that it's very tedious to configure it in the large network. But I mean, when you will actually get into in the production in the real network, you will see a lot of hundreds of static routes. So that doesn't mean that you can't really do static routing in large enterprises. Okay, so we'll see a lot of hundreds of static routes in big bank enterprise level. I mean international bank kind of data centers environment also. So it's not like that we have dynamic routing protocol, so we can configure dynamic routing protocol anywhere. No, I mean this is not really true. I mean this is just from the with the sense that it's very tedious, but it's not. Uh, Always the scenario. So in very big environment, you will see hundreds of static routes configured, because there are challenges with dynamic routing protocols in your production environment. So I mean, it is preferred at many places to use static routes. So you will be seeing hundreds of static routes. So don't think that, I mean, dynamic routes are the only option which is available. There are places where you configure dynamic route, and there are places where though you have to configure hundreds of static route, but you will configure static routes. Okay, and this is the command what we saw. So yeah, so I mean this is again the description of what is the next hop or the exit interface, and we talked about that what is the AD value. Uh, so, so this is the example we will, and this is a permanent entry because this is a static entry, manual entry. So it will not, I mean, it will be there until and unless you remove it from the configuration. Dynamic protocol entries, they can be different at different times. If you receive some, update in your routing protocol, then there might be changes in the routing protocol, because they always compare your existing routing protocol routing table with your routing update, and that is how they update the routing protocol. So I think let's do a lab. Yeah, and then let's see how we are going to configure dynamic routing protocol. Okay, so I mean, if you have packet tracer ready, I'll suggest you open up your packet tracer. Okay, so what is default gateway? So I mean, and this is again part of your routing, and now we are talking about routing. So let's understand about you know your default gateway. So let's say this is one PC, okay, and this is connected to a router, or maybe let's say this is these are not this topology. This is the right topology. Connected to a router, and then this is again connected to a router and another router and then another PC. So let's say this is 10.10.10.0/24. This is some 20.20.20.20.0/24. This is, let's say, 30.30.30.30.0/24, and let's say this is 40.40.40.0/24. Yeah, and this is dot one. This is dot one, two, one, 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 two, and this is, let's say, 40.1, and this is, let's say, 10.1. So the idea is my source is A and my destination is B. So the source address would be 40.40.40.1, and the destination address would be 10.10.10.1. So this guy A needs to talk to this guy B. So this is the source and destination. But the routing table of this PC is what it knows of is 40 network, which is the local network, which is my network, whatever is configured on the NIC card of this PC, and it doesn't know about the rest of the or different networks. So basically, what does the default gateway does? What it does is, it's basically, you can say, it's a kind of a node that basically forwards the packet from source to other networks when there is no routing information about the other networks available. I mean, when you don't have any information about the destination. So basically, in this scenario, I mean, A doesn't know anything about 10 network, right? So I mean, when it doesn't not know about the 10, then where to forward the packet? I mean, how the 40 network will talk to 10 network without knowing, I mean, without knowing that I don't know which is the next hop I need to get to reach here. Yeah. So this is, or you can say, when there is no routing information available about the destination, my routing table only knows about this particular address or this particular subnet which I have. So basically, this default route, so not default route, default gateway, or basically you can call it as your node or whatever. So default means uh, that is the I mean, that is the default. So default what means? I mean, that is the default route which is to be taken when the host does not know where the destination is, right? So it is, basically whatever you are accessing, maybe when you access your when you have, I mean, when you access internet at your home, and I mean, this is your modem at your home, and then you have some IP received from DSCP. So let's say your IP is 192.168.1.1, let's say 1.100, and this guy's IP address is 192.168.1.1, and then this is connected to internet. So you don't know where to go on internet when you are doing any sort of web access, right? Internet based access, any web pages, you don't know about all the addresses, correct? That where these addresses are. I mean, though whatever you are accessing, there is a DNS resolution, and then you got to know about the destination IP address, but you don't know how to reach to that particular destination. So what happens in that case? We define a default gateway on the PC or on the host or on any machine, that if I don't have any information about the network or the destination I'm trying to reach to, I will forward my packet to the default gateway. So default gateway would be the hop or the node where I will forward all my packets, irrespective of the destination. I mean, if I don't know about those destinations, then I will forward my packet to that default gateway. I mean, if I have a route and if I have different kind of connectivity, then I can forward it to different gateways. But default gateway is the ultimate gateway for me to get to the destination. Another example when we talked about earlier, so let's say this is your house, there are different rooms available, and this is the main door. And then this main door is connected to your, let's say this is the main door, and this is your society's road. And then this is how you are getting out, and then you are connecting on the highway. So basically every room has its door, and I mean, they know about the exits from, they are different spaces. But then there is one door which is by which you are getting connected to the highway or to the main road, is your default gateway. So you can say, to understand it better, this is the default gateway to get out from your place to whatever the destination you are heading to. Okay. So 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 basically when I don't know about the destination, this is the next hop, or this is the node to where I am going to forward my traffic. So in this particular scenario, uh, this is 40.40.40.1, this PC, and I don't know how to reach to 10. But when I configure IP and all, you see there is an option of default gateway configuration. So my default gateway in this case is 40.40.40.2. So what will happen? Mm, I'm not going to talk about ARP at this moment. I'm considering that it knows about all those stuff. This will forward the traffic, or this will forward the packet to this default gateway. It will reach here, and then the routing information, on the basis of routing information, that where I need to forward the next packet, which is my next stop, and likewise it will come here, and likewise it will come here. So let's do this lab. I mean, this is what I wanted to tell you about the default gateway. Now let's do this lab. So yeah, so I'm gonna make this lab. So yeah, so let's configure. Okay, see, it by default it took what? Class A subnet mask, but we are using classless, so we are using /24. Okay, and then this is, we have gone define the IP address, and where is the option of configuring default gateway. Yeah, here actually we define, not here, I mean here. So yeah, here is, it is the option of default gateway. What is the default gateway? 10.10.10.2. Okay, and we are not bothered about DNS and all. So that's all. Okay, and let's go to programming, not programming. Where is my command prompt? Basically, what I'm trying to do is, where is my command prompt? No command prompt for this PC. Should be. Anyway, we have defined. Let's. So when you take your mouse, when you hover your mouse on this PC, you see a fast Ethernet. And this is, the link is down because the connected link, the opposite side link is down. This is my IP address, and this is my MAC address. Okay, and then the gateway you see 10.10.10.2 DNS server not set, line number not set. Okay, and all right, yeah. So here is the terminal. That's okay. This is fine. Now, 1 second. Let's see if this works or not. No, this is not working. Command prompt, yeah, command prompt. Terminal. So I'm doing a self ping to verify whether the IP address I've configured is right or not. Okay, the link is down, so I cannot ping. All right. Let me close this IP configuration. This is fine. And further, let me close this. This is fine. This is fine. All right. Okay, let's do the configuration on the router. Okay. Let's go to CLI interface. So let's do what we learned today. I mean yesterday. So I'm getting into configuration mode, and let's say start with our host name. Let's say this is R1, and then do the show IP interface brief to see the interface status. And then let's go to configuration terminal interface fast Ethernet 0/0 IP address. These are the commands, right? 10.10.10. 1 second. Let's first verify this is fast Ethernet 0/0, which is 30 subnet actually. And fast Ethernet 0/1 is on 10 subnet. So let's say, I mean, if we are on 0/0, so configured here 30 subnet. Okay. We are making it as 1, 0, and then we are manually doing no shut, exit, interface fast Ethernet 0/1, IP address 10.10.10.2, 255.255.255.0, no shut, exit, or maybe and I'm going to save the configuration, show IP interface brief. So IP interface fast Ethernet 0/0. I'm just showing you the details that what are the commands which we saw yesterday. You see still the link is down because the other side is down, right? And so interface F0/1. So this is up, right? Because the PC is up and we did a manual no shut on this interface. So interface, see, this is also a command which is available. So we can see all the interfaces here. Now show IP interface brief again. Let's do this is down, like I said, because the other side is down. So let me do a self ping to check whether I'm reachable to myself or not. Okay, now I can reach to that PC also. Yeah, so this is one packet is down and you still don't know the logic of that. So we'll talk about that. We talked about that yesterday, that when we talk about the R, we'll come to know that why that first packet gets dropped. Okay, 1 second, somebody is saying something. That's right. Yeah, so now let's come here. Where now let's come to, so this you see both are greens, which means this segment is fine. Now let's configure this router. Let's go to CLI. No, I don't want to get into initial configuration dialog. So enable configuration terminal, host name R2. Now let's say do show IP interface brief. Okay, interface fast Ethernet 0/0. This is 0/0 on the 30 subnet. So this is we assigned 1 here. So this would be, let's say, 2. So fast Ethernet 0/0, IP address 30.30.30.2, 255.255.255.0 is the subnet mask. No shut, exit, interface fast Ethernet 0/1. Now this is what? 20 subnet, right? 20.20.20. Let's say 2 because 1 is on the PC side. 255.255.255.0, no shut, and I'm going to save the configuration. Okay. So now let's say show IP interface brief. So the both are up. Yeah, this is fine. So let's do a self ping. 30.30.30.2 should be reachable, and 10.10.2, which is my again my IP of fast Ethernet 0/1, which is connected to what? PC, correct? It should be reachable. Wait, not I'm actually pinging 10.10.10.2. It doesn't know about 10.10.10.2 at the moment. Let me do a self ping on 20.20.20.2. And then I'll ping that PC. So this is self ping. Now let me ping my PC. One packet drop and it will be able to ping it. Why? What happened? Okay, we have not configured that PC. Right. So that is the reason it is not. You haven't assigned anything here, right? 20.20.20.1, 255.255.255.0, default gateway is 20.20.20.2. Okay, this is fine. Now it should be able to reach it here. Yeah, okay. Now the command to see the routing table. Okay, so the command to see the routing table is show IP route. Now you see here points to be noted. C means connected. What is connected? 20 subnet is connected. What is connected? 30 subnet is connected. Directly connected, basically. What it means is directly connected. Where I am learning 20.0 on fast Ethernet 0/1. This is what I see from my routing table. Let me bring it here. Let me minimize it for you so you can see simultaneous, I mean, both the screens at the same time. All right. Maybe, yeah. So let me show you the routing table. Yeah. So this is fast Ethernet 0/1, where I'm learning 30 network. I'm learning 31, where it is connected on 0/0, right? It is directly connected on 0/0. And this is directly connected on 0/1. Okay. So and what we talked about, see, you see, there are different options. C connected, S for static, I for IGRP, RAVE, mobile, BGP, and then these all stuffs are there. Yeah. So this is what you see. So now we have seen connected route. Now our agenda is to reach from 10.10.10.1 to 20.20.20.1. This guy should be able to reach here, and then this guy should be able to reply back to this guy. Okay, so let's do this. So let's come to what? Let's come to this PC. I'll show you the routing table at the PC as well. So command prompt. What is the command? Does anyone know? Windows command to, no, not this is not the command. What is the command at Windows? Why it is not? Route print is not the command. The command I forgot.
ipconfig all.
What?
ipconfig all.
ipconfig all. Does it tell about the routing table? No. That is not the command. Route print. I don't know why it is not taking route print, because route print is the command. Not sure why it is not taking. Nobody remembers the Windows command. What I know is route print is the command. Let me open up the CMD of my PC. Let's do a route print here. You see, this is the routing table. I don't know why that packet tracer is not taking. So you see, this is the routing table. You see, IPv4 routing table, active routes, network destination, netmask gateway interface, and then this is the metric, and this is all, these all are, see, this is a internet, this is a public route. Yeah. And I mean, don't think of these interfaces at the moment, what these interfaces are. So this is what I wanted to show. I don't know why it is not taking on the packet trace. I just wanted to show you that the routing table of the PC. So this PC guide doesn't know about anything. It has a default router configured, which is 10.10.10.2.
Just ipconfig.
IP config here.
Yes.
Okay. Yeah. Good. I mean, this IP config just tells you about the configuration, about the interface configuration. It doesn't tell you about your routing table. I wanted to show you the routing table. IP config tells you what are the, I mean, if you have multiple link cards, it will tell you these are the interfaces which are available on this PC, right? I mean, if you see, when we came here, when we go to configuration, there are two interfaces available, fast Ethernet and Bluetooth. So when you do IP config, it tells you about what? It tells you about the interface configuration, not about uh, the routing table. But I don't know why it is not taking. Anyways, that is not a concern. So let's go on router 1. Basically router 0, which we have configured as R1. So let's see the routing table of R1. That does it know about 20 dot network? What networks does it know about? So what is the command to see the routing table is show IP route. So all it knows about is directly connected routes. Yeah, 10 network and 30 network, right? And where it is on which interfaces it is connected. So all right, so let's talk about 20 network. So how do we configure a static route? The command is IP, and then if you do a question mark, a lot of stuff is there. To enable the routing, the command is IP routing, but it already know about the routing. We are static route. To establish a static route, the command is IP route. Yeah. So IP route, then what? Destination prefix. So what is the destination? Destination is 20.20.20. I'm talking about, I'm not doing a /32 route. So when I say /32, so basically when we do a /32, what does it mean? All bits are fixed, right? I'm talking about the IP address. So /32 means host IP. Correct. Has a value. If I put a subnet mask here and then this becomes 0 and whatever the mask I give here, basically the remaining bits would be host bits, which will be 0 actually. But when I do a /32, it's like everything has a specific value assigned. Correct. Guys, please, this is what we learned in subnetting. I mean, this is not that difficult. So what I'm gonna do is I'm advertising the network, not a particular /32 or host route. Okay, I hope this makes sense. 0 and then subnet mask. Okay, not subnet mask. Let me do a question now for you. Then the destination subnet mask, destination prefix mask, what it says, or the subnet mask, and then forwarding, routing, router address, and all. I mean, forget about all these things. Just focus on this. So what is the destination? FA0/0, which is 30.30.30.2. Okay. All right. So now let me do a and show IP route. So there is an entry of static route 20.20.20.0 via 30.30.30.2. Okay. All right. So my R1 knows about 30.30.30. Sorry, 20.20.20.0. Now let's come. I mean, now this guy knows about how many networks? 3 networks. 2 are directly connected. These two, and this is our destination. So in this topology, there are 3 subnets. One is 10, another is 20, and another is 30. So this guy know about what? I mean, let me show you one thing at this moment. If I go to command prompt, if I ping, let's say 10.10.10.2, I can ping 10.10.10.2. You see, a reply packet is coming. Yeah. Let me ping 30.30.30.1, which is this interface. Let's see if it would be able to ping it or not. Would it be able to ping this guy or not? Can you tell how it is able to ping this guy? Guys, this should be, I mean, if you know this logic and understanding, it means you're getting a good understanding about the routing. So I 10 subnet, I know this is locally connected on this link. But how do I know about this? How am I able to reach here on 30 subnet? How this guy is able to ping 30 subnet? Guys, come on. Or maybe
By
another,
static routing.
or maybe ping 30.30.2. Why I cannot ping 30.30.30.2, whereas I can ping 30.30.30.1? This is the same subnet. Yeah, somebody was saying something. Huh? Anyone? Okay. All right. If you don't know, then I know this is a local subnet. This is the default gateway. They are in the same subnet. They can talk to each other. Now 30 network here. This is 30.30.30.1. Basically another NIC card on this router itself. So this guy who is responsible for the inter-domain routing or what we call it as inter-network routing between 10 and 30. This guy knows of 10, this guy knows of 30, and this 30, this address is locally present here. I mean, doesn't matter. This guy knows about this. So it can basically your packet from here, when you're pinging 30 network, it is reaching this interface, then it come to router, and then it should go to the exit interface to reach 3030. But that exit interface or that network is locally present. So it is basically locally processing it. Okay, this is where 30.30.30.1. So it knows about 30.30.30.1. So 30.30.30.1 basically knows how to reach 10.10.10.1. How to reach via 10.10.10.2 using this exit interface, right? So that is the reason it is able to ping this guy. But when it comes to 30.30.30.2, which is this IP, packet from here comes to 10.10.10.2, which is the default gateway. Then it goes to exit interface, which is 30.30.30.1. Then it comes to this interface, which is my destination. So, okay, now it came here. Now this guy will only be able to reply to 10.10.10.1 only when it knows about 10.10.10.1. So does it know about the 10.10.10.1? No, it doesn't, because we haven't configured any static route on R2 telling about the 10 network. So let's check the routing table. Does it know about the 10 network at the moment? No, it does not. So let me configure a route to let it know about the 10 network. Okay. So what that route would be, to go to 10.10.10.0/24. My next hop is this 30.30.30.1. Go via this interface 30.30.30.1. Now I think if I come to this PC and if I ping this guy, it should be able to ping. Earlier it was not able to ping. Now it is able to ping him. It is able to reach him, and then this guy is also able to reply back. Why? Because now it knows about the route which are available in his routing table. To reach 10 network, this is my subnet. This is my next hop where I need to get to. Okay. So now everybody knows about everyone. So I think now this guy should be able to reach here, and this guy should be able to reply back here. So let's see. Let me ping. Okay, this is anyway is pinging. Ping is working. Let me ping 20.20.20. Let me ping 1. See, this is our topology. It is pinging. Now 20.20.20.2 is the other interface of this router. This will also be pingable. So they all are able to ping each other. Let me show you from here as well. Command prompt. Let's ping 50. Let's ping 10.10.10.1. Working. Of course, 2 will work. Of course, 30.30.30.1 will work. Now everybody can ping anybody. Now let me ping from this router to this PC. Of course, when this is working, this will work. I mean, there is no logic, just to show you. I mean, this is going via here, and this guy knows about this network. That is the reason he is able to, pass this information to this guy, and this guy is then traversing through him to here. But just to showcase, you can ping anything from here, from R1, not R1. Yeah, R1, which means router 0. Let's ping 20.20.20.1. Working. 20.2 will work. Again, 30. Is directly connected, so it's gonna work. All right. So this is how you configure the routes, static routes, and this is how you tell them about a different destination network. Okay. So this is nothing but basically think of routing is just the logic, or not the logic, the information. Okay, the information about the destination network, that this is what we are, this is the information by which you can reach to your destination. And then how you are telling that information, or how your devices, routers or switches, how they are getting to know about that information is again a way of logic, or whether it's static or dynamic. But at the end of the day, it's the routing information, that from one place to reach another place, what is the route that I need to take? What are the hops via which I need to go? Okay. So, I mean, don't think of it as, I mean, don't make different kind of understandings or assumptions. It's just the logic being used to, to get that information or to pass on that information on these devices, maybe from one device to another, maybe it's manually, maybe dynamically. That's all. At the end of the day, it's routing. Okay. So yeah. So any questions? Any queries? Any doubt? Just to see the static routing. I mean, just want when you want to see what is the static route configured, you see show IP route static. Now, one more thing. I mean, one more command. If you want to, see any. I mean, this is the command to see the entire running configuration. But I mean, if you want to see anything specific in the running configuration, you don't want to go through the entire, configuration, then let me do a question mark. So you see there is a pipe which says output modifier. So space pipe, and then there are different things which are available, which is different keywords. So begin is basically something which begins with that, and then it will match that line and it will display it in the output. Or if you exclude it, then it will exclude that particular line or command or keyword, and then it will show you the rest of stuff. And there is something known as include. So if you include, it will, so it basically works as a regex, regular expression. It matches that particular keyword and then it displays based on inclusion or exclusion. So maybe I'm going to put it as include, and then let's say, and then after this, your tab will not work. So this is the regex. So regex you manually define, right? So I'm going to put it as, let's say, static. So nothing is there. Okay. And not because there is nothing we have configured using static. What we have done is IP route. So let me show the IP route. So when I did a show running
Pardon, please.
configuration
I
type
couldn't
include IP
understand.
route, it shows me the command, that what is the command which I use to configure this particular route. Or maybe there were two routes. Maybe let me configure another route. Maybe let's say IP route to reach 100 network, which is not there, but anyway, we can configure this. We can, let's say 58.
Excuse me, sir.
Okay. And then you see, so now I'm able to see this also. This is just, a bogus route. But, I mean, what I'm trying to say is it matches the keyword, it matches the regex that you have defined here. And then whatever matching is, it shows it in the output. Okay. So that is how you can use, so this is the command which you will use in your entire career. Show running configuration on any device, pipe, include, exclude, begin, or whatever you will be using at different devices. Okay, so this is what you can do. So maybe now let's do another. So what we did is a lab using 2 routers. Let's do a lab using maybe 3 routers with more subnets. So we will talk about more static routes, and then we will do another lab. Let's say these networks. So I mean, to start with, I mean, before getting into the CLI, verbally, this guy knows about which network, this guy knows about this guy knows about this guy knows about this via this interface, this guy knows about this via this interface. So they are connected networks for this guy. Okay. And for this guy knows about 50 network via this interface, about 40 via this interface, about this via this interface. So these three are connected network for this guy, right? And this guy knows about this network via this interface and this network via this interface. So I mean, if I need to draw the routing table, so let's say R1. So let's say this is our R1, this is our R2, and this is our R3. So what does the routing table of R1 currently looks like? R1 knows of 30.30.30.0 as connected network via FA0/0, correct? And it knows about 10.10.10.0 as a connected network via F0/1. So this is the routing table of this guy. Now R3. So R3 knows of 40.40.40.0 via connected route via FA0/1, right? and then it knows about 50.50.50.0 as a connected route via Ethernet. This is Ethernet 1/0. Okay, and this is basically 30.30.30.0 connected out via fast Ethernet 0/0. Okay. All right. So let's get into the command prompt and then let's configure it. So I think it already we already have configured this particular network on this, but anyway we're going to check. So show IP. If I need to check about the IP addresses configured on the interfaces, what is the command? Show IP interface status. Okay, so status is wrong. Show IP interface, not a status. Show IP interface brief. So yeah, so fast Ethernet 0/0, it's up, and it says up, but yeah, line protocol should be down, so that is down. Now here, you see it's down, yeah, and this is up. So when we configure this one, this will be okay. Now let's talk about show IP route. So it only knows about this. It doesn't know about any other route at the moment. Did we reboot this device? Did we? See, this is the problem with packet tracer. You know, we configured a route on this router, you remember? And we saved also. But when we removed that cable, I don't know how. I mean, removing cables doesn't mean that it will, erase the configuration, but you don't see any static route configured, right? Show run configuration. I mean, you don't see the routing table, of course, so it won't be in the configuration as well. It is there. Now you get to learn one more thing. What? Can anybody tell me? I have these routes available, but they are not there still in my routing table. Or let me do one thing. Let me configure a static route for 30 networks. So this for maybe to reach 50 network, this is my next hop, right? Correct? So IP route to reach 50.50.50.0 255.255.255.0. What is the next hop? 30.30.30.2. This interface, right? Because this is one and this is 30.30.2. Now let me save the configuration as well, IP route. Now let me do a show IP route. Let me do a show run pipe include IP route. I see this route in the routing table here, but I don't see this particular, I mean, it's there in the running configuration, but I don't see it in the routing table. Can anybody tell me why? Okay, no problem. Show IP interface brief. This is still down. Okay. Now let's go to R3. I'll tell you why that was happening. So we are not getting into initial configuration dialog rather. So configuration host name. What is the host name? R3 do show IP interface brief. So everything is down. So this is interface fast Ethernet 0/0 IP address. What is the IP which we need to configure here is 30.30.30.2 and then do a no shut. Okay, and let's see what are the different options available. There are a lot of different options. What we know at the moment is duplex. We know we can configure duplex. So we're not going to bother about duplex and all at this moment, MTU and all. We are doing just basic interface configuration. Okay, so this is up. This is up, and let me save the configuration. Right memory. Okay, show IP interface brief. Now I see this is up. Link is up. Let me do a show IP route. It will show me the connected route here. Now I'm gonna go to here again. The line protocol is up, and I'll see show IP interface brief, show IP route. Now I see all the routes, a 50 route which is available, the static entry which was not available earlier in my routing table, but now it's available. See, earlier when I did a show IP route, the only route which I could see is this route, which was connected via this. But what I didn't see is the route of 20 and the route of 30. So the 20 route is, sorry, the 30 route is available via, one second, what is this? Yeah, this is available via, because this is configured. This is configured earlier. I need to remove that route basically. I mean, this is as per our previous topology, remember? This route. This was the previous topology. I mean, this used to be our 20 destination and this was 30. So let me remove this configuration. I mean, even if I don't remove it, I mean, it will make sense. So let me remove it. So I do a no and then paste. It is not. So this is the problem again. The packet tracer copy. Here it goes like copy and paste. Okay, and show run pipe include IP route. Now there are two routes, show IP route. So there should be three routes. Two are directly connected and one is static route. So why we were not seeing this earlier? So if the interface via which you are learning that particular subnet is down, though you might be having a static entry in your routing table, it will not show you in your routing table. I mean, what I'm though you are having that entry in your running configuration or in your startup configuration or in your configuration rather, but it won't be there in your routing table until and unless that interface is up. For example, I mean, we are talking about static routes until now. But let's say if we were talking about dynamic routing protocols, and let's say here we are running some dynamic routing protocol, here we are running some dynamic routing protocol, and these are the interfaces which are participating in that routing dynamic routing protocol. If this interface goes down, it cannot communicate anything in this direction or it cannot receive anything from this direction. Yeah. So the logic is this interface has to be up to exchange any information. So the same logic is also applicable on the static route, though it is locally available here, but the logic is same. If this interface is not up, the route will not reflect in my routing table. Okay. All right, now let's configure further. Let's go to this. Now we need to talk about, we need to configure this interface, Ethernet 1/0. We haven't assigned IP address, right? So IP interface status, not status, believe. So let's go to interface Ethernet. What happened? Nobody says anything. Let's go to command global configuration mode, Ethernet 1/0. The IP address, what is the IP address? 50.50.50.2 255.255.255.0, no shot, and it will be up. It should be green. Why it's still green? Show IP interface brief. Okay, so let's go to this PC configuration. IP configuration. Let me configure this PC. We are configuring this PC. So IP 50.50.50.1 255.255.255.0 50.50.50.2. All right, this is done. Now let me show this is up and show IP interface brief. This is up, this is down, but this is down. Why this is down? We don't need to do anything here. Make it up. Port status is on. What is the problem? Why it is not? Let me do a single self-ring 50.51 working. Why this is not up? Hmm. This is not up. Why it is not up? Otherwise, this is on. What is the problem? What is the problem? Hmm? Can anybody guess what is the problem? Why this is not up? Let's go back on router. So run Ethernet 1/0. We did a no shut. Let's come on this PC. All right, so now let's configure F0/1. Okay, show IP interface brief. This is unassigned and down. So let's go to global configuration mode, interface fast Ethernet 0/1. IP address, what should be the address? 40.40.40.1 and 40.40.40.1/255.255.255.0. Enter, no shut. Now let me tell you one shortcut. Let's say show IP route. So I have written this. If I press Control U, entire line would be erased. So this is a keyboard shortcut. Okay. So if I do Control U, everything is gone. Show IP route, and then let me execute it. Control U, it's gone. Now if I press, let's say Control A, my cursor will come to the beginning. Okay. So you see, it is at the end now. If I do a Control A, it is here. If I do a Control E, it will go to the end. If I do a Control U, it will erase everything. Okay. All right. Now there is another something. If I do Control W, one by one erase. It will erase, one by one. So another Control W, now it's gone. Another Control W, it's gone. Another Control W, it's gone. And if I do Control U, everything is gone in one go. Okay. So these are the keyboard shortcuts. All right. So this is up and we have configured. Let's do a self ping. Let's say 40.40.40.1. It's pinging. I think 40.2 should not be ping because it does not exist at the moment. I mean, this guy doesn't know about 40.40.40.2 at this moment. I mean, it knows, but there is something else which, I mean, it doesn't know, but there should be a different IP which is configured, I guess, as per our previous topology. I think 30.2 should be configured here to show IP interface brief. Yeah, like I said, 10/0, it's 30.2 configured as per our previous topology. So there is, now it's time to see another command. I'll show you another command. So show run include interface fast Ethernet 0/0. Okay, and then the keyword is wrong. So fast Ethernet 0/0. So it doesn't show. Okay, show running configuration. Pipe include interface fast Ethernet. I think it will not work like this here. No, it will not work like this here. Show run. Let me do this. What I want to show you is where is 0/0? Here 0/0. So let's me try again if it works or not. It doesn't work in this on the routers basically, but yeah, let's try. It doesn't show us anything. So what I'm trying to say is, let's go to. I am going to erase the configuration, or maybe there are two ways of doing it. First, let's go to interface fast Ethernet 0/0. So there is already a IP address assigned on this address on this interface, which is 30.30.30.2. And what I'm gonna do is I'm gonna assign another IP, let's say 40.40.40.2, and let's see if it let it assign or not. It has. I mean, it did not throw any error. So let's do one thing. Now let's check show IP interface brief. So you see what it did? It actually replaced the configuration. Whatever was there earlier on that interface, it has replaced it with the new IP, correct? See, earlier it was here 30.2, now it's 40.2. Okay. I hope this is fine. Now let's do a self-ping to check if this is right. Okay, this is right. Let me ping.1. It will work. Okay, all right. And let me do a ping to 20.20.20.2, which is my F0/1, and it should be working, and .1 should be working, which is PC. Yeah, all good, right? Memory. Now we are done with the configuration, the initialization of, the interfaces, the IP address configuration. Now the target is that I must reach from PC0 from here to here. I must be reaching from here to here and here to here, and likewise the other way around. I mean, reaching from one place to another is basically route, and then the reverse route should be available. That is the reason that is how the whole communication will work. So let's go to PC0 and let's see what and all network it can reach. Okay. All right. So I'm here at PC0. So what is my IP? I can always check with if config, IP config. No, if config. I'm saying if config, but what? IP config. So my IP is 10.10.10.1, and this is my default gateway. So basically, I mean, I can ping my default gateway, which is this IP 10.10.10.2, and this is 10.10.10.1. Now let me see if I can reach any IP in this network. Let's say 30 network. Let's say ping 30.30.30.1. Will it work? Will it work or not? Hmm? Will it work or not?
It must.
Yeah, it should. It will work. This is locally on this router, and the router is what doing what? It is doing an internet networking between this 30 subnet and 10 subnet, and it knows about both the networks. It will work. This is what we did in the previous lab. Guys, come on. Okay. Pinging. All right, now let me ping 30.2. It will also work. Should work. Should work. Should work. Why it's not working? And this guy is able to ping 30.1 but not 30.2. Why?
Because
Anybody?
it is not connected locally.
No, that doesn't mean, I mean, not connected locally is fine, but that is not the right answer, I guess.
It is on the interface of the other router.
And
It is the interface of other router.
that is fine, but then that doesn't tell me anything.
Yeah, that's why we need the static route.
Basically, this router doesn't know about the 10 network at this moment. Let's go to this router, check the routing table. It
Show
doesn't
IP
know about the
route.
10 network. So that is the reason the packet is reaching here. If you do a packet capture, the ICMP echo from here to 30.2 reaching here, when the reply packet from here is not getting anywhere, because this guy does not know how to reach to 10.10.2. Okay, so let's
Right.
configure a route on R3. See the routing table, it doesn't know about the 10 network. That is the reason it is not able to, send back to 10.10.10.10.0. So what is the next hop? 30.30.30.1. Now it should be able to ping. See, now it's working because this guy now knows do show IP route, how to get back to this guy. Yeah.
Can you repeat?
Yeah.
So what? So the question was, this guy was able to ping this IP, but not this IP. This was not working. Why it was not working? Because this router didn't know the route information of this network, which is 10.10.10.0. So when we configure a route here, which means this guy knows about this network, and then it will work. All right. Now let's do one thing. Let's ping from here to here, and let's ping 50.0 dot. I'm sorry, ping 50.50.1. It's working. How is it working? Does this router know about 50 network? Let's check. Did we configure any router out on this router about the 50 subnet? Oh, we did. We did. It has that route. So that is the reason it is able to forward this packet here. So the source is 10.10.10.1. The destination is 50.50.50.1. The packet comes here. This router knows about, okay, how to reach here via this. It reaches here. Now this guy know about this network locally present. It forwards the packet to this guy using this exit interface. It comes here. This guy gets the packet. It replies to 10.10.2. It doesn't know about 10.10.2. What it knows about, I don't know about any network. All I know about is my default gateway. So I'm forwarding packet back to my default gateway. Now default gateway knows. Default gateway is what? Interface of this particular router. Now this router knows that where can I get, how to get to 10.10.10, right? It knows about via this interface. So it forwards this packet to this, and this guy knows about this locally. Okay, this guy is connected on this interface, and then this forward the packet to this interface via this interface to this guy, and that is how they are able to communicate. Now let's come again on this PC. Now let's see if this PC can reach 40 network or not. It should be able, not. Can it ping 40.40.1? This PC? Guys, come on.
Yes.
It can ping. Destination host unreachable. Oh, what is this message? Why it's unreachable? Do we know why?
Int route.
Huh?
Int route for FA0/.
Now, don't go by the interface. Tell me about the network. That who doesn't know about which network?
40.40.0.
And who doesn't know about it? Come on. Come on, the guys who already have done CCNA. I'm not saying it. I mean, I'm not trying to criticize or anything. Just if you, I mean, try to answer.
You doesn't know 40.40.0.
Who doesn't know? Who doesn't know?
10.10.10.
No. I mean, how can you say that this network doesn't know about this network? You say that this particular device doesn't know about this network.
Okay, PC0 doesn't know.
But I mean, I have a default gateway configured. So do I bother whether I know about any network or not? I will forward everything to my default gateway. So it doesn't matter whether I know about this network or not. So what is next? So that is how you do troubleshooting, hop by hop. What is next?
Okay, then 30.30.0 doesn't know about 40.
Again, you're saying it wrong. Not 30.30. What does a network know about a network, or does a device knows about a network?
Router.
Router 0. Basically, does it know about 40.40.40.0? Does it know about that network or not? Guys, come on.
No.
It doesn't know. I mean, we haven't configured anything about 40. Does it know about 40? No, it doesn't. So what is happening here? When this guy is pinging 40.40.1, he is able to forward this packet here. But then this packet is getting dropped here. So that is the reason you are seeing a message of unreachable here, because the packet is reaching here, but then this guy doesn't know where to forward further. Got the point? So let me configure a route. Show IP route. And I mean, not show IP route. IP route via what?
30.32.
30.30.30.2. Yeah. Now let's go to PC. Working?
Yeah, it's working.
Because earlier it didn't know. The router didn't know how to reach 40 network. Now tell me, let me minimize this. Tell me if this guy can reach 40.2 or not. Will it work? Why it's not working?
Because 20.20.20 is not in its routing table.
That is the wrong answer.
Because router 1 doesn't know about router 0 doesn't know about router 1.
Okay, let's see if that is the scenario or not. Do show IP route. Okay, it doesn't know about the 20 network. Okay, let's configure IP route 20.20.20.0 subnet mask of /24, and the next of is 30.30.30.2. All right, now it knows. Let me show it again. It knows about 20, and let's see. Will it work? It is still not working. Why it's not working? There are two. I mean, when we talk about, I mean, just additional information. When we talk about ping ICMP, at that time, I'll tell you. You see, now you're seeing a request timeout. Earlier, you also said destination host unreachable. So when you see what kind of response, we'll talk about them. I don't know if you noticed or not, but in one scenario, you saw destination host unreachable, and now you are seeing request timeout. So why different kind of messages when the scenario is same? I mean, you are not able to reach there. So we'll talk about it, whether you noticed or not. So yeah, so we configured the route here. Now why now this guy can reach 40.40.40.1, but why he still cannot reach 40.40.40.2?
Maybe from the other end, it is not configured.
So the logical answer is this guy can reach until here, and this is a locally connected interface. So this router knows about this network, and this router knows how to get back here. But the obvious answer is once it comes here, this guy doesn't know how to get back to 10.10.10.0.
Yeah, the same thing I want to say.
It doesn't know. Okay. So let's do a config route, config terminal, IP route 10.10.10.0 and 40.40.1. Let's check the routing table again. Now it knows about 10.0, 10.10.10.0 via 40.40.41. Let me ping it. Working. Okay. Now let's ping 20.20.20.2. This interface. Will it work? Does it my PC know about 20.20.22? Does it know about it? Speak up, please. Doesn't matter. So PC doesn't matter, because I already have a default gateway. So the question comes whether my router 0 knows about it or not. I think it knows, or does it not? I don't know. I need to see the routing table. So let me ping. Unreachable, which means, where is my router 0? Which means it doesn't know. Show IP route. It knows, but somebody else doesn't know. It knows. So let's go on router 1. Let's see if it knows or not. Show IP route. It doesn't know. There is no entry of 20.network here. So what is happening when I'm pinging from here to this particular IP? The router is the packet is getting here. It knows about 20. It forwards to this interface, but then this guy doesn't know where to forward further because there is no 20 network in its routing table, right? So let's configure it. IP route on 20.20.20.0/24, and the next hop is what? 40.40.40.2. This interface, right? Let me do one thing. Let me change it, or not now. Shall I change it now? No, not now. I wanted to show you something else, but not now. Would be too much. Now it knows. Let me ping it now. It's working. Because this guy knows how to reach here and this guy knows how to get back to 10 network, right? Now let me ping this guy, 20.1. Will it work? It will work. Because when router is able to reach back, this guy doesn't know about anything about any network. It knows about the default gateway. It forwards the packet here, and then this guy know about, this guy. So now let's ping from this guy to this guy. From maybe let me open a terminal from here. Ping, let's say 50.50.50.1. It is not working. So let's see. Let's go on this router. Let's see if it knows about the 50 network or not. It doesn't know. IP route 50.50.50.0/24. What is the next hop? This is the next hop. 40.40.40.1. Let's go back to PC. It's working. Let's go to PC3. Of course, the written way it will work. If this way it is working, the other way will also work. Okay. So this is how you configure. Basically, you need to know and understand if all the hops or the router in the network, they know about the desired networks which should be known to them. I mean, it totally depends on from where to where you want to communicate, and that is how. So that is what we discussed, in the beginning, that my routes should know about my devices should know about about the networks. So the one point which we talked about the static routing, that being a network engineer or an admin, you should know about the whole network. The idea is whole network. When we say whole network, that is what we were talking about in static routing, right? That if I don't know, then it will be difficult for me. So administrator or network engineer must really understand the internet work, or how they are connecting to each other, or how they are connected to each other in order to configure things. So if you don't know, if you don't remember, I mean, knowing is not a challenge, but to know that you have to verify a lot of things. You have to go to on different hops, and then uh, you have to check the routing tables, the connectivity, how it's available, how it's not available. Yeah. So that's the logic. So yeah, so I think static routing is clear. In the next class, we will do dynamic routing. Maybe in the next class, we will finish at least. Let's see how much we complete in the next class. Okay, any questions?